Oh, hey, money. Thank you. Oh, we have this money. Yes. What are we gonna do with this money? Oh. Hey, how are you? You are poor and I'm rich. Do you wanna multiply your money? Yes! There's something called compounded quarterly interest, and you can double your money in approximately 8 years. We want that! Come, let me show you how.
We are M to the fourth math class, and we're going to present a problem of compound interest. Our team is conformed by Toti, Mariana, and me.
The problem says, a man invests $5,000 in an account that pays 8.5% per year. A. Find the amount after 3 years if the interest is compounded quarterly. B. How long will it take for the investment to double when compounded quarterly? C. If the interest is compounded continuously, how does the answer to be changed? And D. Express the continuous interest model as a function of time and sketch the graph.
Compound interest is calculated not only on the initial principal, but also on the accumulated interest of prior periods. Compound interest differs from simple interest in that the simple interest is calculated just as a percentage of the principal sum.
We researched and we found this formula, where A represents the amount accumulated, P the initial amount, R is the interest rate, N the compound per period, and T the number of periods.
Thing we have to do is to find the amount after 3 years if the interest is compounded quarterly. So we substitute into the general equation, and that is A equals P times 1 plus R over N, and all of that raised to NT. Our values are P equals 5,000, that is the initial amount. R is our interest, that is 8.5%, and we turn that into decimals, and that gives us 0.085. And N is the periods, and due to the problem that is compounded quarterly, we have 4 periods. And then T is the dependent variable, that is the number of years. So we have to find the amount after 3 years, so it's 3. And then the substitution is 5,000 plus 1 plus 0.085 over 4, and all of that raised to the 12, because it's 3 times 4. And that gives us 6,435.09. So the amount after 3 years, if compounded quarterly, will be $6,435.09. And this is the graph of this problem, and the initial amount is 5,000, and then we can see that after 3 years our amount has accumulated to $6,435.
Well, the next question is, how long will it take to the investment to double when compounded quarterly? So, in this problem we use the same formula of the past one, just that we need to isolate t because it's the time. So we substitute all the values we have, and we put the 10,000 here because it's the double of 5,000 and it's what we want to get. So then we pass the 5,000 that is multiplying, dividing to the other side, and it's 2 equals 1 plus 0.085 over 4, all raised to have logarithm of base 2 of 1 plus 0.085 over 4 equals 40. So now we pass the 4 dividing, and we solve it in a calculator. So the result will be 8.24 years. So he will have $10,000 in 8 years, exactly in 8.24 years.
Next question is, if the interest is compounded continuously, how does the answer of B will change? We found a new formula where A is the final amount, P is the principal amount, E is the mathematical constant E, which is 2.72, R is the rate of interest, and T is the time in years. We need to isolate T, so we substitute to the formula, which is 10,000 equals 5,000 E to the 0.085 times T. To do this, we need to do a logarithm, which is logarithm of 5,000 of 10,000 equals 0.085t. We pass 0.085t dividing to isolate t. We did it with a calculator and the answer was 8.1547. So he will get $10,000 in 8 years, exactly in 8.15 years.
Next question, and the last one, is express the continuous interest model as a function of time and sketch the graph. So we have the general question, and we just need to substitute the values and write it in terms of the independent variable, that in this case is t. So we just write the f of t, that is the function of t, equals 5,000 e raised to the 0.085t. And then we sketch the graph. This graph is an exponential graph.
Now we are going to explain to you our flowchart. So first, we search for the formulas using compound interest and in quarterly and continuous interest.
Then we substituted the values in the formula of quarterly and continuous interest for A.
When we needed to get the time, we isolated t using a logarithmic function. Then we just solve it.
We wrote the function in the terms of t, time, that is the independent variable.
And finally, we graph all of the functions using a special software.
The amount of money after 3 years, if you have $5,000 at the beginning, and if the interest is compounded quarterly, would be 6,435.09. If the interest is still compounded quarterly, it will take approximately 8 years to double. It means to reach $10,000. If the interest changes and may transfer to compounded continuously, it will take almost 8 years also to reach $10,000.
The continuous interest model expressed as a function of t is 5,000e times to the raised to the 0.085 times t. So we can conclude that a compound interest can be considered as an interest of an interest, which makes the bank deposits grow at a faster rate than a simple interest.
This compound interest is very useful for people because if we use it, we can make more money than the one we invested. This problem can happen in real life, so it is useful to have the formula of the compound interest and the compounded quarterly interest.
See guys, how compounded quarterly interest works so well?
Yes! We love M4 Mafia!
Now we are rich!
We are very rich! We multiplied our money! We had 5,000 and now we have 10,000!
See? It's pretty well.
It's
It's
so
just
easy.
in 8